Welcome back to the deep dive. I have to admit, usually when I prep for these, I have a cup of coffee, I read through the materials, and I feel, pretty good. I feel like I've got a handle on things
Right.
today. Today I've been staring at the stack of papers you sent over for about 48 hours, and I genuinely feel like I'm holding contraband.
I know that feeling.
Like, I feel like if a physicist walked in here right now, they would arrest us.
It does feel a little bit like we're plotting a coup, doesn't it?
It really, really does. Because we aren't just talking about a new discovery or some cool piece of tech. We are talking about taking the most famous equation in human history.
Well, one everyone knows.
Maybe the only equation your average person on the street actually knows. And we are effectively saying, yeah, but there's a typo.
Well, not a typo. Let's be very, very careful with our words here before the pitchforks come out.
Okay, fair.
We aren't saying there's a mistake. We're saying there's a context that has been missing.
Yeah.
For 100 years.
We're talking about E equals mc squared, Albert Einstein, the Holy Grail. And the premise of this deep dive, based on these papers on structured vacuum and spectral geometry, is that Einstein wasn't wrong, but he was talking about a special case.
A theoretical case.
A perfect scenario that doesn't actually exist in the real world.
Exactly. And that is a distinction that changes literally everything. Einstein described the asymptotic limit of free space. So imagine a universe that is completely empty.
No walls, no planets, no atoms.
Nothing. Just infinite void-like space. In that specific, idealized classroom example, E equals mc squared is perfect. It is the law.
But we don't live in an empty classroom.
We do not. We live in a universe full of stuff. We live in a universe of boundaries. Atoms have boundaries.
Planets have boundaries.
Stars, galaxies, you have a boundary. And the core argument of the stack is that when you introduce boundaries, when you introduce geometry, you change the rules of energy.
And that brings us to the new variable, the guest of honor today, the chi-t factor, the Greek letter chi with a little t.
That's it. Topology factor.
So the equation becomes E equals mc squared times this chi-t thing.
That's the proposal. E equals mc2 chi.
And the claim here, which again feels massive, is that if you just add this one little factor, if you just account for the geometry of space, you don't just fix a few rounding errors.
Not at all.
You unify physics, biology, and theology into a single framework.
It sounds like hyperbole, I know. It really does. Unifying physics and biology is the holy grail. Throwing theology in there usually gets you laughed out of the conference.
Right, that's where you lose the audience.
But the logic in these sources is surprisingly rigid. It's not woo-woo spirituality. It's based on very hard, very testable physics regarding the nature of light and the vacuum.
Okay, so before we jump off the deep end, I need a tone check. I am the guy who loves science but barely passed calculus. You are the expert. I'm going to be skeptical today because when someone tells me Einstein missed a spot, my alarm bells go off.
And they should. That is a healthy reaction. And honestly, the authors of these papers anticipate that. They call what they're doing honest bookkeeping.
Honest bookkeeping. I like that.
They argue that modern physics has been, well, a little lazy with its accounting. We've been ignoring the energy costs of geometry. Today, we're just going to try and balance the books.
All right, let's balance the books. To understand T, we have to start with the vacuum. This was the first hurdle for me. When I think of a vacuum, I think of outer space. I think of nothing. The absence of stuff.
Which is what everyone thinks.
But these sources are screaming that empty is a lie.
It is a lie, or at least it's a very useful fiction that we've outgrown. In the 19th century, sure, we thought space was empty. But quantum mechanics killed that idea a long time ago.
So what is it?
The vacuum is not a void. It is the ground state of the electromagnetic field.
Okay, ground state. Unpack that for me. What does that mean in plain English?
Think of a guitar string. Just sitting there on the guitar, not being played.
Yeah.
Even when you aren't plucking it, the string is there, right?
Yeah.
It has tension. It has the potential to make sound. If you pluck it, you get a particle of photons, a little packet of energy. But if you don't pluck it, the tension is still there. That potential is still there.
So the vacuum is just potential.
The vacuum is basically an infinite field of guitar strings under tension. It is humming with potential energy, a sea of possibilities.
So it's noisy. It's not quiet.
In a quantum sense, yes. It's incredibly noisy. It's a spectrum of modes. Think of it like a choir. In free space, that empty, infinite space we talked about, that choir can sing any note it wants.
High notes, low notes.
Deep bass, screeching soprano, everything. It's a full, continuous spectrum of wavelengths.
Okay, so I'm floating in space, and this invisible quantum choir is singing every note imaginable all around me.
That's a perfect way to visualize it. That hum is the zero-point energy. It's the baseline energy of the universe. Now, here's where the geometry comes in.
The boundaries.
The boundaries. What happens if you take that infinite choir and you shove them into a tiny room?
They get claustrophobic. They're not happy.
They get limited. This is the crucial point. A sound wave or a light wave needs space to exist. A low bass note has a long wavelength.
Yeah.
It physically takes up space.
Right, you can feel it in your chest.
Exactly. So if you put that choir in a room that is smaller than the wavelength of the bass note,
Yeah.
what happens?
The bass note can't be sung.
It is physically excluded. The mode is suppressed.
Okay.
And this brings us to the Casimir effect. This is the proof. This is the experimental evidence that this isn't just a fun analogy.
The metal plates. I remember reading about this in a science magazine years ago, but walk me through it like I'm 5.
Okay, you take 2 metal plates, perfectly flat, perfectly smooth. You make sure they're uncharged, no magnetism, no static electricity.
No tricks.
No tricks. You put them in a vacuum chamber to get rid of all the air. Then you push them incredibly close together. We are talking nanometers apart.
So smaller than a wavelength of light.
Much, much smaller than a hair.
Yeah.
Almost touching. And when you get them that close, something completely bizarre happens.
They move.
They physically push themselves together. There is a measurable physical force clamping them shut.
And since they aren't magnets, and there's no air, the question is, what is pushing them?
Exactly. If space is empty, there should be no force whatsoever. But there is a force. And the reason is the choir.
Ah.
Outside the plates, in the big open vacuum chamber, the vacuum choir is singing all the notes. Full spectrum. You can think of it as high pressure.
Okay.
But between the plates, in that tiny nanometer gap, the gap is so small that the long wavelengths, the deep bass notes of the choir, can't fit. They're excluded from the party.
So the choir inside the gap is smaller?
Much smaller. It's a much quieter choir. Fewer modes are allowed to exist. And fewer modes means less energy density.
So you have high pressure outside, low pressure inside.
And nature hates a pressure difference. The external vacuum pressure, the full choir, crushes the plates together.
That is the smoking gun, because that's a physical force generated from nothing.
From the geometry of nothing.
That proves that the shape of the space, the geometry of the plates, changed the energy of the vacuum.
Geometry determines energy. That is the mantra for this entire deep dive.
Oh.
If you change the boundaries, you change the energy density. Full stop.
Okay, I'm with you on the plates. I get that. But how do we get from 2 metal plates in a lab to rewriting Einstein's life work? That still feels like a huge leap.
Well, think about what Einstein's equation EmC2D2 is actually doing. It's a conversion factor. It tells you how much energy is locked up in a given amount of mass.
Right, it's the exchange rate.
It's the ultimate exchange rate. But it assumes a constant background. It assumes the vacuum energy, the zero-point energy, is the same everywhere all the time.
It assumes the high pressure outside the plates, the full choir.
Exactly. It assumes our chi-t factor is equal to 1. It assumes the full, unconstrained choir is singing. But the sources argue that in the real world, matter isn't floating in free space. Matter is a bounded system.
What do you mean?
An atom is a tiny cavity. The electron shells create a boundary. A proton is a boundary. A DNA helix is a boundary. A living cell is a boundary.
So inside an atom, we are between the plates.
We are always between the plates. We are always in a structured, constrained environment. And because we are in a structured environment, the vacuum energy density is different. It's not 1.
It's chi-chi.
It's chi-t.
So chi-t is basically a ratio, a correction factor.
Precisely. Chi-t, there's the ratio of bounded energy to free energy. It's the energy of the small choir inside the plates divided by the energy of the big choir outside. If you are in that idealized free space, it's 1. But if you are inside a hydrogen atom or inside a crystal lattice, it's not 1.
So the effective energy, the energy available to do work or to act as mass is mc² times that ratio.
That's the formula, the effective MC2.
This sounds, it sounds logical, but I'm going to play the angry physicist for a second. There is a principle called Lorentz invariance. It's like sacred. It's the rule that says the laws of physics don't change just because you're moving or looking in a different direction. Doesn't this idea of variable energy just completely break that?
This is the Steelman argument from the source text. And
Sure.
it's the most common and most important objection. Hey, you can't have the laws of physics changing depending on where I am.
Right. If I bake a cake in my kitchen, it should work the same as baking a cake on Mars, assuming I account for gravity and atmosphere and all that. The fundamental physics shouldn't change.
And it doesn't. But the rebuttal here is very, very sharp. The authors argue, Lorentz invariance applies to free space. It applies to the void. But the moment you build a box, or introduce the Casimir plates, or even just have a single atom, you have created a rest frame.
A rest frame.
You've created a distinct here. The box is sitting there. It has walls. It has a definition. You cannot demand that a closed box with defined boundaries behaves in the exact same symmetrical way as infinite nothingness.
You've broken the symmetry just by building the box.
You've broken the symmetry. The boundary conditions define the physics inside the boundary.
I guess that's fair.
Huh.
My living room has different aerodynamic rules than the stratosphere because I have walls and furniture and air.
Exactly. You've created a local environment. The other objection, and this one a bit more technical, is about waves.
Okay.
Critics say, look, inside a cavity you get standing waves. They just bounce back and forth. They don't go anywhere. So the net energy flow is zero. So we can just ignore it in our calculations.
That sounds like standard accounting. If I give you $5 and you give me $5, we're even. The net flow is zero.
Right. But the expert in the source calls this lazy accounting. He says we shouldn't be looking at the flow, which might average to zero. We should be looking at the spectral sum, the total tension in the system.
The tension again.
Think of a weightlifter. He's holding a massive barbell over his head. He's just standing there, not moving. The bar isn't going up or down. According to flow physics, he's doing zero work because work is force times distance, and distance is zero.
But if you ask the weightlifter,
He's sweating. His muscles are trembling and burning. The tension is massive. The potential energy is huge. The source argues that the vacuum inside a cavity is like that weightlifter. Even if the waves are standing still, the energy is there. It's stored in the structure. Ignoring it is like ignoring the weightlifter's effort just because the bar isn't moving.
okay, that analogy lands. That makes a lot of sense. So we're shifting from a physics of stuff moving around to a physics of tension and geometry.
Which brings us to the most relatable analogy in the whole stack, the bar gradient, or as I like to call it, cooking on Mount Everest.
Let's do it.
Yeah.
Because this is where the whole cheat thing stopped being a math symbol for me and started making real intuitive sense.
So imagine you're in your kitchen at sea level. Standard atmospheric pressure, we call it 1 bar. You put a pot of water on the stove. At what temperature does it boil?
100 degrees Celsius, 212 Fahrenheit. That's
Yeah.
just the rule. It's a fact.
That is the rule at that pressure. Now pack your bags. We are teleporting you to the summit of Mount Everest. You set up a little camp stove. You put the same pot with the same water on the fire. When does it boil?
It boils at a much lower temperature, around 70 degrees Celsius, I think. That's why it's hard to cook up there.
Right, because the air pressure is lower. The constraint on the water is less. It's easier for the water molecules to escape and turn into gas.
Okay.
Now here's the key question. Did the water change? Is it different H2O?
No, it's the same stuff.
Did the laws of thermodynamics change? Did physics suddenly break on top of the mountain?
No, of course not.
So what changed?
The environment, the pressure.
The constraint environment, the geometry of the atmosphere changed. And because the constraint changed, the energy threshold required for the phase transition boiling also changed.
Constraint writes the choir, and the choir writes the energy.
Exactly. The atmosphere acts on the water molecules just like the Casimir plates act on the vacuum. The plates are the pressure. They change the boiling point of the vacuum energy.
That is really clean. It's a powerful analogy. So basically, Einstein was giving us the recipe for boiling water at sea level.
And he was right. It's an incredibly important and accurate recipe for that specific condition. But he didn't tell us what to do on Everest, or in a submarine, or inside a black hole. This new theory, this 1mc2 tria 2, provides the formula for every altitude.
Okay. I'm sold on the physics. I'm on board. The logic holds. I'm sold that boundaries change energy. But now we have to make the jump that I think is going to be the hardest for people to swallow.
Next chapter.
We are moving from metal plates and boiling water to DNA.
The biological connection. This is where it gets really interesting.
The source material pivots to something called the quaternary principle. And it makes a claim that sounds spiritual. All being is light.
It does sound spiritual, but they mean it in the most literal, physical way possible. They aren't saying light is a nice metaphor for truth. They are saying that matter, the stuff you're made of, electrons, protons, neutrons, is fundamentally light in a standing wave.
A standing wave, like the one in the Casimir cavity?
Yes, specifically a toroidal standing wave. Picture a donut.
That smoke ring.
The theory is that a fundamental particle is just a photon that has been trapped in a self-reinforcing loop. It's light chasing its own tail in a little geometric vortex.
So matter is just knotted light.
Knotted light, that's a great way to put it. Propagating light is energy. Knotted, standing wave light, is matter. And time, they argue, is light observing itself. The fundamental substrate of reality, the clay that everything is made of, is light.
Okay. If we accept that for a moment, and it's a big if, how do we get to biology from there?
We have to look at the structure of light itself. Light isn't just a blob. The electromagnetic field has a very specific, irreducible architecture. It has 4 components. 4, you have the electric field, you have the magnetic field, you have the direction of propagation, which way it's going in space, and you have the scalar, or frequency component, which relates to time. You physically cannot have a photon without all 4 of these aspects being present.
So light is a 4-part system.
It is a quaternary system. Look around. Space-time is a quaternary 3 dimensions of space, 1 of time. 3 plus 1 before.
Okay, numerology makes me nervous. I have to push back on this a little. Just because 2 things have the number 4 doesn't mean they are related. A car has 4 wheels and a dog has 4 legs, but a dog isn't a car.
That's a very fair point. And the sources would agree. A simple numerical coincidence means nothing. But this isn't just about the number. It's about the underlying mathematical structure.
Okay.
The source brings up William Rowan Hamilton. He's a giant in the history of mathematics. Back in the 1800s, he was trying to figure out how to calculate rotation in 3D space.
It seems simple, right? We live in 3D space.
Right. You'd think you'd need 3 numbers, an X, a Y, and a Z. Pitch, yaw, roll. That's what he thought. He spent years banging his head against the wall. The math kept breaking. You get these things called singularities, what pilots or gamers call gimbal lock, where the coordinate system just collapses and the math stops working.
I've definitely experienced that in a video game. The camera just freaks out.
Exactly. Hamilton, in a flash of genius, realized that to describe 3D rotation smoothly and without singularities, he couldn't use 3 numbers. He needed 4.
Why 4? Where does the 4th one come from?
He needed a 4th, non-spatial dimension to act as a scalar magnitude, a real component to stabilize the 3 imaginary spatial components. The moment it clicked for him, he was so excited, he famously carved the formula into Broom Bridge in Dublin.
The formula was pi dollar xilidollar equals $2 equals chi2 angular equals 1.
That's the one. He had just invented quaternion.
And quaternions are what we use today for
everything.
Yeah. Right. Computer graphics, satellites.
Spacecraft navigation, robotics, animation. If you played a modern video game and the camera pans smoothly without that gimbal lock, you are thanking William Rowan Hamilton and his quaternions. But the source argues that Hamilton didn't just invent a cool mathematical trick.
He discovered the native language of the universe.
The native language of light. Because light is a 4D phenomenon propagating through 4D spacetime, the mathematics that governs reality must also be 4D. Quaternions are the natural language of the substrate.
Okay, so we have 4D light and 4D math. Now, bring it to DNA.
This is the moment. Look at the genetic code. The instruction manual for every living thing on this planet, from a tiny bacterium to a giant blue whale to you and me. It is written in an alphabet of exactly how many letters?
4. Adenine, thymine, guanine, cytosine, A, T, G, C.
Why 4?
I don't know. The standard answer is what? It was an evolutionary accident. The first life form happened to use 4, and it just stuck.
That's the standard view. It's a frozen accident. But think about it from an engineering perspective. Computers use binary 0 and 1, 2 states. It works incredibly well. Why didn't life use 2? Or, on the other hand, why not 20? There are 20 common amino acids that build all our proteins. Why restrict the code to just 4 bases?
The deep dive theory says it's because of the light.
It says that if all being is light, and light is inherently quaternary, then biology, which is just a very complex organization of matter, must be built on that same quaternary foundation. DNA is biological scale light organization. It's using the native alphabet of the universe because it has no other choice.
It's not just the number 4, though, is it? The source points out the pairing, which is even more specific.
Yes. This is where it gets much harder to dismiss as coincidence. In quaternion math, the components pair up in opposites. In DNA, A always pairs with TG, always pairs with C. You have 2 pairs of complementary opposites.
It mirrors the mathematical structure.
It mirrors the mathematical structure of the light field perfectly. A positive pairing and a negative pairing. It's the same pattern.
That is, Well, it's uncanny. It's hard to dismiss as a coincidence when it's that specific.
And then there's the shape, the famous double helix.
The twisted ladder.
We all know the spiral. But the source argues that the double helix is what you get if you take a linear helix like a spring and you wind it around a curved torus. That donut shape we talked about earlier, it is a toroidal projection.
Wait, hold on. You said a particle of matter is a toroidal standing wave of light?
Yes.
And now you're saying DNA's geometry is a toroidal projection?
You see the pattern. It's a fractal hierarchy. The same fundamental geometry repeats at every scale.
Lay it out for me.
At the tiniest Planck scale, you have what physicists call 4D quantum foam. At the atomic scale, you have 4 quantum numbers that are required to describe the state of any electron. At the cellular scale, you have DNA with 4 bases organized in a toroidal geometry. And at the cosmic scale, you have 4D spacetime.
It's the rule of 4 all the way up and all the way down.
The takeaway from this section is this. You cannot write 3D instructions on a 1D piece of paper. It doesn't work. You need a 4D medium to encode a 4D reality. DNA uses 4 bases because it is encoding information in the 4D medium of light. Biology isn't separate from physics. It's the same geometry, the same chai tea, playing out at a different scale.
I feel like I need to sit with that for a second. We usually treat biology as this squishy stuff and physics as this hard math stuff, but you're saying biology is just crystallized physical.
Crystallized light geometry.
Yes.
That's the argument.
Okay. Let's keep moving before my brain melts completely. We've done space with vacuum, we've done matter with DNA and light. Now we have to tackle the big one, time.
Time is always the hardest part.
The source has a paper titled The Geometry of the Present Slice, which honestly sounds like the title of a sci-fi thriller, but the concept is about our own blindness.
It's about limitation. The central idea is that we as observers never ever possess the whole universe at once.
Because of the speed of light, right?
Correct. We are trapped in what's called a light cone. If you look at the moon, you are seeing it as it was 1.3 seconds ago. If you look at the sun, you're seeing 8 minutes into the past. If you look at the Andromeda galaxy, you're seeing 2.5 million years ago. You never see now everywhere. You only ever see here and now.
So the idea that there is a universal now, that right this second on Alpha Centauri, something is happening simultaneous to us talking.
The source argues that as a fiction. The quote is, "The totality is not. You cannot have the whole universe occupying a single present slice. It violates the fundamental geometry of relativity. The universe is not a simultaneous object. It is local information being revealed to you sequentially."
So if time isn't a giant block that already exists and we're just moving through it, how is it created? The source uses a word that I usually associate with making rock candy: nucleation.
This connects right back to quantum mechanics. Imagine reality before you look at it, before an interaction. It's a wave. A superposition of states. It's a fuzzy cloud of probability.
Schrodinger's cat is both dead and alive.
Exactly. It exists in a state of potential. Nucleation is the moment of interaction, the moment of observation, the moment the wave hits a boundary. At that instant, the wave collapses into a definite coordinate. A single dot on the graph. The cat is either dead or alive.
And that collapse is a single tick of the clock.
Exactly. Time is not a flowing river that carries us along. In this model, time is a sequence of these nucleation events. Tick, tick, tick. Each interaction collapses probability into history. It writes one frame of the movie.
So why does it feel like a river? Why does my life feel smooth and continuous?
Because you are huge. You aren't a single particle being observed once. You are made of trillions upon trillions of atoms, all interacting constantly with each other in the environment. You are nucleating trillions of times every second.
So blurs together?
It blurs into smooth motion. Just like a movie is just a series of still photos played fast enough that your brain sees it as continuous movement. But at the fundamental level, time is being written frame by these collapses.
That gives me a bit of an existential crisis. I'm just a nucleation machine.
In this framework?
Yeah.
Yes. You are a boundary condition. You are the machine that turns the fog of probability into the concrete reality of history. You are the needle on the record player, reading the groove of potential into the music of existence.
Okay, that leads perfectly into the final and probably most controversial section of this deep dive. We've hit the limit of physics, we've hit the limit of biology. Now we are pushing into theology.
This is where many scientists get very uncomfortable and decide to leave the room. But the source material leans right into it. It argues that if you follow the logic of light and geometry to its ultimate conclusion, you end up with a physical definition of God.
But not God in the sense of a bearded man on a throne in the clouds.
No, absolutely not. The source takes the ancient phrase God is light and interprets it not as a metaphor, but as a rigid physical definition.
Okay, break that down. How can God is light be a statement of physics?
To understand this, we have to talk about geodesics. A geodesic is just a fancy word for the path an object takes through space-time.
The straightest possible line.
The straightest possible line through a curved environment. Now, we as humans are massive objects. We are made of matter. We move on what are called time-like geodesics.
Meaning we experience time.
We experience duration, we wait, we age, we have a past that we remember, and a future that we anticipate. We're stuck in the sequence, the flow.
Right.
But light, a photon, it moves on a null geodesic.
Null meaning zero.
Meaning zero space-time interval.
Yeah.
This is a standard mind-bending fact of Einstein's relativity that people often forget. If you could write on a photon, time stops. It ceases to exist.
So for a photon, the journey doesn't take any time.
None. For a photon, the moment it is emitted from a distant star and the moment it hits the retina in your eye, even if that journey took 1 billion years from our perspective, are the exact same moment for the photon.
Zero duration.
Zero. Light lives in an eternal present. It does not experience time or distance.
Whoa. Okay, so if God is light, then God experiences no time.
Correct. And this gives us a physical framework for the concept of transcendence. God is not in the universe, waiting for things to happen sequentially like we are. God is the null framework, the state of being outside of time, where alpha, the emission, and omega, the absorption, are the same point.
That actually makes the classic omni properties make physical sense. Omnipresent.
If you experience zero distance, you are everywhere at once.
Omniscient.
If you experience zero time, you see the beginning and the end simultaneously. There's no past or future to be ignorant of.
That is surprisingly coherent. It stops it from being magic and makes it a property of geometry. God is the null framework within which our time-like universe manifests and plays out.
Exactly. And this brings us full circle back to the Casimir plates. The theological section brings back the plates as an analogy for time itself.
Yes, I loved this visual. This really clicked for me.
Think of the past as one plate, the ultimate boundary behind us. Think of the future as the other plate, the ultimate boundary ahead of us.
And the present, our entire experience reality, is the gap between them.
We are living inside the temporal Casimir gap. We live in the tension between alpha and omega, and just like the vacuum pressure pushes the metal plates together, the tension between the memory of the past and the potential of the future is what drives the universe forward.
And this leads to my favorite line in the whole stack of papers. It's a simple 3-word sentence. Darkness is not.
It's such a powerful ontological claim. We tend to think of darkness as a thing, a force, the dark side, the opposite of light.
An active presence.
But physics says no. Darkness is simply zero photons. It has no being. It has no energy. It has no properties. It is just the limit marker where light ends. It's an absence.
So evil or darkness in this model is just a lack of information, a lack of being.
Essentially, yes. It is an absence, not a presence.
Yeah.
And this has a cosmological implication, too. If light is the substrate of all existence, if all being is light, then there can be no outside.
Goodbye, multiverse theory.
Goodbye, multiverse. The source argues that the concept of outside implies geometry. Over there is a geometric concept. But geometry is a property of the light field. If you have geometry, you are still inside the light field. You cannot have a universe outside the universe. It is a logical contradiction. One egg, a single, absolutely closed, self-contained system.
That is somehow both claustrophobic and also kind of comforting. We are all in the same room.
It's a unified room. There's no escape, but we're all in it together.
Okay, we are in the home stretch here. We need to wrap up the cosmos. We have these 2 giant elephants in the room of modern physics, dark matter and dark energy. Usually scientists just wave their hands and say, we don't know what this stuff is, but our equations need it, so let's call it dark.
Right. It's missing mass and missing energy.
Yeah.
They're placeholders for our ignorance.
But if you look at the universe through the lens of chai tea, what happens? What if dark energy isn't some mysterious cosmic fluid pushing the universe apart?
What if it is simply the Jai-T of the temporal Casimir gap? As the universe expands, the boundaries, the plates of past and future are moving farther apart. That changes the geometry.
Which changes the allowed modes.
Which changes the spectral density of the vacuum. Which changes the overall energy density. We measure that change in energy density and we call it dark energy. But it's not a substance. It's just the geometry of time acting on the vacuum.
It's a bookkeeping error.
It's an honest bookkeeping correction.
And dark matter, the stuff that supposedly holds galaxies together.
The source calls it the coordinate momentum of space propagating through time. Essentially, space itself has inertia. It has weight because it has geometry. These aren't missing particles hiding under the cosmic sofa. These are quaternary geometric effects. They are artifacts of our incomplete accounting.
It all comes back to geometry every single time.
It does. Let's just recap the chain one last time, because this is the spine of the whole episode.
Let's do it.
Number 1, constraint modifies spectrum. The pressure on Everest changes the boiling point. The metal plates change the vacuum square.
2, spectrum modifies energy. The notes of the choir determine the total energy. This gives us Wien knowledge equals MC2 to Lecter.
And 3, this applies everywhere. It applies to atoms under pressure, to the vacuum in a cavity, to biology with DNA, and to the entire cosmos with the dark sector. It's a universal principle.
And the grand synthesis is, Einstein is the special case.
Einstein describes the perfect, empty, theoretical void, but reality, the biological, physical, theological reality we actually live in, is structured space. And structured space has a factor. It has a Chinese.
You know, usually when we do these deep dives, I feel like I learned a new fact. Like, oh, did you know that bananas are technically berries?
Right. A good piece of trivia.
Today, I feel like I need to relearn how to see.
That's the danger and the power of this stack of sources.
Mm-hmm.
Once you realize that Einstein was zoomed out, you start seeing the connections everywhere. You look at a leaf and you see the quaternary code. You look at the night sky and you see the temporal plates. It's an interconnected, spectral, geometry-dependent universe.
And it puts us, the observer, right in the middle of it all, not as a passive bystander, but as a participant.
An active participant, yes.
Which brings us to the final thought. We always like to leave you with something to stare at the ceiling about tonight.
Here it is. We talked about consciousness being quaternary light observing itself. And we talked about that observation creating nucleation, the process that turns probability into a tick of time.
Right. We are the nucleation machines.
So if that's true, if you are the boundary condition, if the light of potential is interacting with you to collapse the wave and create reality,
Then the question is,
if you are the one writing the history of the universe, tick by tick, with every interaction and every observation, what kind of time are you writing right now?
that puts the responsibility right back on our shoulders, doesn't it?
It puts it all on us.
Well, on that slightly terrifying note, I'm going to go observe some coffee and nucleate a sandwich into my stomach. Thank you for guiding us through the deep end today.
Always a pleasure.
And thank you for listening. This has been The Deep Dive. We'll see you in the next slice.
All right, let's jump right in. We are about to unpack a pretty radical idea, a framework that looks at one of the most famous equations in all of science and says, hey, that's just the beginning. This is a deep dive into a source that really challenges how we think about reality itself, and it all starts in a place you'll definitely recognize. E equals mc squared. I mean, you know it, I know it. It's the absolute bedrock of modern physics. It's this beautiful, simple equation that tells us mass and energy are basically the same thing, just different forms, connected by the speed of light squared. It works, it's powerful, it unlocked the atom. But what if it's not the whole story? What if that famous rule is actually just a special case? You know, the rule that only works in a perfect, clean, idealized universe, which isn't exactly the one we live in. And that's the key, right there. Einstein's equation works perfectly for a vacuum, for this idea of a totally empty, featureless space that goes on forever. But our universe, it isn't empty. It's messy. It's full of boundaries and shapes and all sorts of geometry. And once you start accounting for that, things get really, really interesting. So that brings us to our first big idea here. There's a real-world, totally measurable phenomenon that shows us exactly where that standard equation starts to, well, hit a wall. So in the quantum world, the vacuum is anything but empty. It's this simmering sea of energy, of quantum fluctuations. The source material we're looking at even calls it light in its ground state. But here's the kicker. You can actually change the properties of that energy just by introducing physical boundaries, just by changing the geometry of the space. And the perfect proof of this is something called the Casimir effect. It's amazing. You take two metal plates, they're uncharged, and you stick them super, super close together inside a vacuum. Now, according to standard physics, nothing should happen. They're just sitting there. But they don't. They actually get pulled toward each other, Why? Because those plates create a boundary that changes the vacuum energy in that tiny gap between them. You get a real measurable force from what should be nothing, which proves that geometry isn't just a passive background. It's an active ingredient that literally changes the energy of a system. Okay, so if geometry can actually change energy, how in the world do we calculate that? Well, this framework introduces a brand new tool for our mathematical toolkit, designed to do just that. It's called chi, or the topology factor. The easiest way to think about it is like a little number that tells you how much a specific shape or boundary is warping the energy of a system. So in totally wide open space, chi is just 1, no effect. But the second you introduce a boundary, like those Casimir plates, the value of chi changes. It's like a mathematical knob you can turn that adjusts for geometry. So what does that do to our famous equation? Well, this framework isn't about throwing Einstein out. It's about adding to his work. The effective energy of a system becomes mc², but then it's multiplied by this new chi-t factor. It's basically saying that the energy of a thing isn't just about its mass. It's about the mass and the shape of the space it's sitting in. Look, to make this feel a bit more real, just think about boiling water, right? At sea level, standard conditions, water boils at 100 degrees Celsius. That's our EMC². It's the rule. But if you climb a mountain, your environment, the geometry, has changed. The atmospheric pressure drops, and suddenly the rule changes. Water now boils at a way lower temperature. The water itself hasn't changed, but its boundary conditions have, and that changes the energy rule. Chi is kind of like the atmospheric pressure for the universe's energy. Okay, so we've got this geometry factor. Cool, but what if this isn't just some tiny correction for a weird quantum experiment? This is where the source material we're exploring argues that this is actually a clue pointing to a much, much bigger pattern, a universal pattern that's woven into the very fabric of reality. And this is where things get really wild. The idea expands into what the source calls the quaternary principle. The argument is basically that the number 4, it's not just a number, it's a fundamental signature, a structural blueprint that shows up again and again and again at every single scale of the universe. And you start to see this pattern everywhere once you look for it. Let's start with the basics. Light itself has 4 key parts, right? An electric field, a magnetic field, the direction it's going, and its frequency. They're inseparable. And what about the stage where everything happens? Space-time. It has 4 dimensions, 3 of space, 1 of time. There it is again. Okay, let's zoom way in, down to the atom. How do we describe an electron, one of the basic building blocks of you and me? Well, you need a set of 4 quantum numbers to pin down its exact state. Not 3, not 5, you need exactly 4. The pattern just keeps going. And now for what might be the most mind-blowing connection of all. Let's jump over to biology. The code of life itself, DNA. It's written in an alphabet with 4 letters. Just 4 nucleotide bases, A, T, C, and G, build the instruction manual for every living thing we've ever found. The argument here is that this is no coincidence. This is the universe speaking its native language. So when you lay it all out like this, it's pretty stunning. From the quantum world of space-time and atoms, to the biological world of DNA and proteins, all the way up to the cosmic scale of galaxies, this 4-part structure just keeps showing up. The source claims this isn't just a series of coincidences. It's a fractal. It's a self-repeating pattern that tells us there's a single fundamental rule underneath it all. And that leads us to the grand finale, the part of this framework that tries to tie all of this together into a single, unified, and honestly pretty mind-bending vision of what reality actually is. So here is the ultimate claim from the source. All being is light. And that's a very specific claim, not made from light, but literally is light. In this view, matter is just light trapped in a standing wave pattern. Space is the geometry that light creates as it moves. And that rule of 4 we just saw everywhere? Well, that's just the natural, 4-dimensional language of light expressing itself on every possible scale. Now, if you look at the universe through this lens, the biggest mysteries in cosmology start to look different. In the standard view, we're hunting for these mysterious things called dark matter and dark energy. But in this quaternary view, they're not things at all. They're large-scale geometric effects. Dark matter isn't some particle we haven't found yet. It's the momentum of space-time itself. And dark energy? That's seen as a cosmic-scale version of that Casimir effect, a force being generated by the expanding geometry of our universe. And that really brings us back to the core idea, which is summed up perfectly in this quote from the source material. Topology is not decorative, it is causal at the spectral level. What that really means is that shape and structure and boundaries, they aren't just the passive stage where physics happens. They are an active cause. They fundamentally dictate the energy and the rules of our universe. So that leaves us with one last big provocative question to chew on. If this framework has it right, if reality is truly written in a geometric language, and everything from a strand of DNA to an entire galaxy is just an expression of light's four-part nature, what is the universe trying to tell us?